this advanced challenge, I'll give another example of using recursion. This example will search for a number in a sorted list. Even though this example will have numbers, words or strings can be sorted in alphabetical order too. Imagine you have a list of thousands of items. If my program tries to find a particular item in the list and always starts with the first list item, then marches through the list one item at a time, the search can get very time-consuming and take far too long. Also notice that if it searches for something that's not in the list, the entire list will need to be scanned. In the real world, lists can get very long. Phone directories, star locations for an observatory's telescope, lists of serial numbers for all the phones a company created and sold. If the list is too long, no one can wait for the search to finish when looking one at a time. I hope this example starts to get you aware of this kind of problem. A very simple approach is to have the list sorted 2, 4, 6, and so on, instead of having the items in a random order, 8, 20, 2, and such. If the list is sorted, then I can have a procedure block logically split the list in half and look in the half that could have what it's looking for, ignoring the other half that's too high or too low in the sorted order. The procedure block can then recursively call itself to look at the chosen half and keep choosing halves until it's finished. First, I'll need a sorted list. I won't need the cat for this example. I'll hide the cat and use the stage. A good chance to show something a little different. I'll go to Data, make a list. I'll call it Sorted Numbers. I'll always want to make sure the list is empty when I start. I'll delete all items. I'll need to add an item, and I'll want to use a loop to create some items for me. I'll go to Control, repeat until, put the add in the loop, attach it to the delete. I want a value to put into the list. Go to Data, make a variable, call it value. Okay. I want the first value to be 2. Repeat until value is greater than 20. Operators, greater than 20. Back to Data, get value. I'll add the value into the list, and I'll need to change the value. I'll change by 2 so I have only even numbers. I'll make this a procedure block to initialize the list. Make a block, initialize list. All right. I'll use this to initialize it. Move it over. Call the block when the green flag is clicked. Now when the green flag is clicked, value will be set to 2. The list will be cleared. Until the value is greater than 20, it'll add 2, increase it by 2, 4, 6, 8, up through 20, then the loop will finish. I'll move the list over, and the value. Run it. A little bit too long to display right now. Now I have my list of even numbers from 2 through 20. I want a recursive procedure block to search for a value, more blocks, make a block, call it recursive search. It'll have 3 options for numbers, 1, 2, 3. The first one will be the value, call that num. The second one will be low index, which will be the location in the list to begin looking. And the third number will be high index, which will be the value of the location of the last item to look at. Okay. Move it down. I want to call it. I'll try the number 8 first. 1 will be the index for the first item. I want to use 10, really the length of the list. I'll go to Data, get length of. Then no matter what the list size is, it'll work correctly. I'll move this over a little bit. Now when I click on the green flag, the list will be initialized. It'll pass 8 for num, 1 for low index, and 10 for high index, so it'll search the entire list. First I want to make sure that low index and high index are valid values. They're invalid if low index is greater than high index, or if low index is less than 1, or if high index is greater than the length of the list. Go to Control, if else. I want to check some OR conditions, operators, get a couple over here. It's invalid if low index is greater than high index. There's one of the cases. It's invalid if low index is less than 1. It's invalid if high index is greater than the length. I'll duplicate. It's invalid if any of these three are true. I'll add them into the ORs. I'll shrink the stage so I have more room. Put these together. Add them into the if. But how can I let the caller know the results? It'll save the value of the index in the list when a match is found, or it'll save 0, an invalid list value, when nothing is found. Go to Data, make a variable, call it found index. Okay. Set found index to 0 when I'm given invalid values. Next, I'll handle the case when low index is equal to high index. Control, if else, operator is equal. If low index equals high index, then it can't split the list anymore, and it needs to see if num matches the value. I'll use this if, duplicate. I can get rid of these. If num is equal to this item in the list, data, item in the list, use low index. If num is equal to the low index item of the list, then it matches. So I'll want to show that it matches the low index value. Otherwise they don't match, so I want to set found index to 0 to indicate there's no match. Now if low index and high index don't match, I need to determine which half of the list to look at. But how do I do this? I'll use a diagram to show how. I have a list of 10 even numbers in sorted order from 2 to 20. Since the numbers are in order, I can imagine the list has two halves, items 1 through 5 and items 6 through 10. If the number I'm looking for is greater than the 5th item, I'll ignore the first half and use the second half. Otherwise, I'll ignore the second half and use the first half. I'm quickly ignoring half the list each time it makes a choice. If this were a list of 1,000,000 items, then I've just eliminated 500,000 items that I won't have to look at. How would this work if I were looking for the value of 8? 8 is not larger than the last item of the first half, so I ignore the second half and use the first half. I'll keep repeating splitting and choosing halves until I'm down to one item. So I'll split this in half, 2 through 6 and 8 through 10. Now 8 is greater than the last item in the first half, so I'll use the second half and ignore the first half. And again, I split this into two halves. 8 is not greater than the last item of the first half, so I ignore the second half. I have only one item now. If it matches my value, I found it. Otherwise, the number's not in the list. That's the general idea. Now I'll do it again with more detail, but don't lose sight of the general algorithm. Split and ignore until down to one item. The list isn't copied for any of the splits. Instead, it keeps reducing the area it's searching through by carefully changing the index values of the low and high ends of the half it's looking at. I'm looking for 8, so num is 8. And I'm looking at the entire list, so low index is 1, high index is 10. It'll calculate half of the difference and save that in the half-diff variable. Take the high index value minus the low index value, and divide that by 2, then remove any fraction beyond the decimal point by using floor. 10 minus 1 is 9. 9 divided by 2 is 4.5, but floor removes the 0.5, so it's left with 4. It's important I have nice integer values, since it's specifying items in the list. I'll add half diff to the low index, so I have the index of the last item in the first half. If that's the index of the last item in the first half, then one more than that will be the first item in the second half. In this case, 1 through 5 is the first half, 6 through 10 is the second half. 8 is not greater than the last item in the first half, 10, so I ignore the second half and use the first half by making this call. Then I split and ignore again on the first half. Now low index is 1 and high index is 5. 5 minus 1 is 4. 4 divided by 2 is 2. Floor of 2 is still 2. And 2 plus low index is 1 gives 3. 8 is greater than the last item in the first half, so I use the second half and ignore the first half. It'll make this call this time. Then I split and ignore again. 8 is not greater than the last item of the first half, so I ignore the second half and use the first half. It'll make this first call again. I have only one item now. Low index and high index are both 4. The value matches, so it was found. Recursion's a little tricky at first to understand, but hopefully you can start to see how powerful it can be to look at some solutions this way. Remember, this is an advanced topic, so don't worry if it's too challenging for you right now. The important thing is you're aware of recursion and you've been introduced to it. I'll go back to scratch and implement it now. I'll create the half-diff variable now, make a variable, call it half-diff. Okay. I want half of high index minus low index operators minus high index minus low index divided by 2. I'll get floor to remove any fractional part after the decimal. Floor. Add that in. I'll set high diff to this value. Back to data. Set high diff in the case when low index is not equal to high index, so I'm still searching through halves. I'll make a little more room. Move this over. Slide this up. Next I need to choose when I'll use the first half or the second half. Go to Control. If else. If the number is greater than the last item in the first half, I want to make a recursive call for the second half. More blocks. Search. If the number is greater, operators, greater than. If number is greater than the last item of the first half, data, item. The last item of the first half is low index plus half diff. Go to operators plus low index, data, half diff. If the number is greater than the last item of the first half, call myself with num again. The second half starts with an index value of 1 greater than this. Duplicate. Back to operators. Add 1 to it. 1. The index of the first element in the second half is 1 greater than the last element in the first half. The second half ends with high index. I'll duplicate this call and change it. Save this. Get rid of high index. Low index for the beginning of the first half. The index for the end of the first half is low index plus half diff. I can get rid of that. When low index equals high index, the range can't be split anymore, so it looks to see whether num is matching the item. If it is, low index is returned. Otherwise, it doesn't match, and 0 is returned. Else, low index is not equal to high index. The range needs to be split. Take half of the range. If the value is greater than the value of the last item of the first half, use the second half, else use the first half. The first half is from low index up to low index plus half the difference. The second half begins one greater than the end of the first half and goes up through high index. It's ready to run. I'll enlarge the stage, move found index and half diff into the center of the stage. I'll stop the program and run it. Found index is 4. The fourth item in the list is 8, and 8 was the number I was searching for. I'll try some more values. I'll go to Sensing, use the ask command, and it'll ask, search for which value. Instead of passing 8, I'll use answer now. And now I'll use value to save the value that was found. But what if a value is not found? In that case, I'll set value to empty to indicate the value wasn't found. I'll make some room, move this down, Control, if else. It's an error if found index is 0, so I'll check for the error. Operators, equal, back to data. If found index is 0, then I'll want to set value. I'll remove the 0 to empty. Otherwise, I'll want to set value to the item in the list. Copy found index. Move this down a little bit more. When found index is 0, that's an error. Value will be empty. Otherwise, value is going to be set to the item for found index. It's ready to run. I'll stop it and start it again. I'll choose 12, so the answer should have the index value of 6. 12, check mark. Found index is 6, value is now 12. The correct index is being returned, so the correct value is being set. You can try a couple more valid values. I'll stop it. Try the first value, 2. 2. Found index is 1, the first item in the list. Value is 2. Good. Try it again. Try the last value, 20. Check. Found index is 10. The value is 20. Good. I'll try a couple cases that'll fail. An interesting failure case you might have even thought of was at the very beginning when the list is split in the middle. What happens with 11? Is 11 just kind of slip through? I'll show it'll work fine. Stop. Green flag. Enter 11. OK. Enter. Found index is 0. It's not in the list. And value is empty. The failure was correctly detected. Try another value. What happens if the value is too large? It should be for this set here where high index was too large. Run it. 100. Run. Found index is 0, and the value is empty. I'm finished with this challenge. I encourage you to play with the program and get comfortable with recursive calls. Try changing the program. Try making the list larger. Try using words instead of numbers. For an advanced change to this advanced challenge, when the T key is pressed, T for test, and verifies all the pass and fail cases when the number value is 1 through 21. The loop will run 21 times, verifying all the correct and incorrect values. To do this, remove ask and answer and use a loop instead. Don't worry if that advanced change is too much. It is important you make some of your own changes and get comfortable with recursive calls, but above all, have fun with the program.